Okay, so we were dealing with fractions, LCD. Now, let's have a look at these type of examples. Here we're dealing with squares. Okay, there's no fractions here. We got a times t squared minus r squared is equal to t squared. We need to make t the subject of the formula. However, t occurs in more than one term in this equation. There's a t squared, there's a t squared. So basically t is part of t squared. So what we need to do is we need to isolate t squared first. Okay, so first we need to isolate t squared. Okay, so how do we do that? Okay, let's take all the t squares to one side. So we got a t squared minus t squared is equal to r squared. So I've got all my terms with t squared on the left hand side of the equation. Now there's a minus sign separating. When there's a minus or a plus separating, we need to factorize. So we will take out t squared as a common factor. So once I take out my t squared, I'm left with a minus 1 is equal to r squared. You check, t squared times a is a t squared. T squared times minus 1 is minus 1 t squared. Now, this is multiplication. There were two terms. Now, this is just one term, two factors. So now, t squared is equal to r squared all divided by a minus 1. Okay, now we have achieved our goal here, which was to isolate t squared first. Now, I want t, this is t squared. So you know we've done irrational equations. If I want to find t, what I'm going to do is I'm going to find the square root of both sides. But remember that when you are finding the square roots, there are two possibilities, plus or minus. Okay, so the square root of t squared is equal to plus or minus the square root of r squared divided by a minus 1. So the square root of t squared, so t is equal to plus or minus the square root of r squared divided by the square root of a minus 1. Remember that this is a fraction. Okay, I need to raise the numerator to the power and the denominator to the same power. The power is half, or in other words, square root. Okay, so that's plus or minus the square root of r squared is r, and the square root of a minus 1 is the square root of a minus 1. There's nothing we can't go any further there. So that is it. So remember, if you have more than one term in an equation, what you're looking for is part of these two terms. You need to rearrange it, take out a common factor, and then if you have a square, find the square root of both sides. Now this one, there's already a square root here. Okay, so we got t is equal to pi over 2 multiplied by the square root of m times a divided by this symbol is called lambda. You encounter this in electrotechnology, engineering science. Okay, so now what do we need to do here? What we are looking for is lambda. Where is lambda? Lambda is part of this fraction, ma divided by lambda. Where is this fraction? It's inside. Okay, the square root, so it's a square root of ma divided by lambda. So if I want to access the denominator or anything inside here, I need to get rid of the square root. So normally we isolate the surd. Remember when we did surds, we isolated if there's many terms, but there's only one term here. This is multiplication, so we can go and square both sides in the beginning. So I can square both sides there. So I need to square Here I have pi over 2 times the square root of ma divided by lambda, and that is my t. I'm squaring both sides. So let's see what happens. So that will be t squared is equal to, here, this is going to be pi over 2 squared times the square root of ma over lambda squared. Remember, you square all factors here. This is multiplication exponent laws here. So we got t squared is equal to, you square the numerator, that's pi squared. Square the denominator, 2 squared, that will be 4. Square the square root, you end up with just ma over lambda. Okay, now we got rid of the square root. Okay, what we can do is now get rid of the fractions. Okay, so what I can do here is, this is what I have at the moment. I have t squared. On the left hand side I have pi squared times m times a divided by 4 times lambda. Okay, if I want to get rid of this fraction, okay, what I can do is multiply by 4 times lambda over 1 on the right hand side. Why am I doing that? So there won't be any fraction. 4 and 4 will cancel, lambda and lambda will cancel. Whatever I do on the right, I must do on the left. So that's 4 times lambda divided by 1. Okay, so now I have 4 lambda times t squared is equal to pi squared times m times a, because remember 4 and 4 cancel, lambda and lambda cancel there. So now I want only lambda, so this is the same as lambda times 4t squared is equal to pi squared times ma. Okay, so now all I have to do is divide by 4t squared. So lambda is equal to pi squared ma, all divided by 4t squared. It's the same as multiplying by 1 over 4t squared on both sides. Okay. Okay, so just be careful with this one. I think this is the one where the textbook final answer is wrong. So you just double check that one. Let's go to a similar example to C. It's similar in a way that we want to make B the subject, but there's more than one variable of what you're looking for. Just like here you had to make T, there was more than one T there. So what do? We follow the same technique. If there's more than one variable, you need to get all the common variables on one side. Okay, so here we have a fraction. If you have a fraction, remember what we do. Get rid of the fraction first. So I can multiply by, so let me just do it here. Here I have x over 1 is equal to, I got my h, that is 2a plus b divided by 3, and then I have a plus b there. Okay, I want to get rid of the fraction, so therefore I got 3 times a plus b, so I'll multiply by 3 times a plus b over 1 on the right hand side. So the fraction, the denominator will cancel there. Whatever I do on the right, I will have to do on the left, so that's 3 times a plus b over 1. Okay, it's the same as cross multiply. So here, let's see what happens. Okay, so here we got 3 times x, which is 3x, and we got our a plus b there, and here we got just h, and that's 2a plus b, because these two cancel. So let's remove these brackets. Right, so why do I want to remove the brackets? Because I want this common b on one side there. So 3x times a will be 3ax, 3x times b, that will be plus 3bx. Here, h times 2a, that will be 2ah, and h times b, that will be BH. Okay, so what do we want here? Remember, this is what we're looking for, B. So we take the b's, or all the terms that have the variable b, on one side. Okay, so I got 3bx. You can take bh to the left, or you can take 3bx to the right. It doesn't make a difference. Okay, let me take it to the left, so there'll be minus bh is equal to, here I got my 2ah minus 3ax. Okay, so now I can take out b as a common factor here. Here, okay, a is common. I can take it out if I want to, but it's unnecessary to do all that. We're not interested in the right hand side here. But for the sake of factorization, if you want to, you can take out a as a common factor, so you're left with 2h minus 3x. Here you took out b, so what are we left with here? We are left with 3x minus h. Okay, so now it was two terms, now it's one term, but two factors. It's multiplication, so to find b, we will use division to get rid of 3x minus h. So therefore, b is equal to a times 2h minus 3x, all divided by 3x minus h. Now, okay, now this is b, b is the subject of the formula. But now remember that at this point here, I chose to take bh to the left hand side, so it became minus bh. So what happens if you took 3bx to the right hand side? Okay, then let's say if you took 3bx to the right hand side, then how will your final answer be? How will your final answer look? Okay, what will happen is the final answer will be like this. You'll end up with a, and then you'll end up with 3x minus 2h, all divided by h minus 3x. Okay, it's just that all the signs will be different. So remember, if you take this to the right hand side, it becomes minus 3bx there. Okay, then if you take out b as a common factor, you got if you take this to the right hand side, 3bx will become minus 3bx. You take 2ah to the left, it will become 3ax minus 2ah. Okay, so have a look at these two here. Okay, if you had values to substitute, like for h, x, and a, you can substitute it here, and you can do the same here. You must come to the same answer.